Hi, this presentation is all about the overview of statistical and induction learning. So I will discuss the overview of statistical learning. Statistical learning theory is the basic theory behind contemporary machine learning and pattern recognition. So, machine learning, pattern recognition, and statistics, kani silang tulo, they are closely related fields in terms of methods, but of course, they are distinct in their principal goal. It suggests that the theory provides an excellent framework for the philosophy of induction. So, kani siya nga theory, ina siya ay maayong structure sa iyang set of principles. Diin pwede ang philosophy of induction mo based ani nga theory. Kaning philosophy of induction, it's all about the various approaches in specifying the problem of induction. It represents another paradigm which assumes there is an unknown objective probability distribution that characterizes the data and the new cases about which inferences are to be made. The goal being to do as well as possible in characterizing the new cases in terms of that unknown objective probability distribution. So, the basic theory attempts to specify what can be proved about various methods for using data to reach conclusions about new case. Statistical methods in artificial intelligence. Statistical learning in artificial intelligence is a set of tools for understanding data. In simple words, statistical learning is understanding from training data and predicting on unseen data. This set of tools is for machine learning that uses statistics and functional analysis. These tools broadly come under two classes, supervised learning and unsupervised learning. Generally, supervised learning refers to predicting or estimating an output based on one or more inputs. So, kaning supervised learning is a machine learning that's defined by its use of labeled datasets. Kaning mga datasets, gidesign ni siya para maoy mo train or maoy mo supervise sa algorithms para sa pag-classify sa mga data or pag-predict og accurate nga outcome. So, by using labeled inputs and outputs, mas sayon siya sabdon og mas accurate iyang pag-measure. Unsupervised learning, on the other hand, provides a relationship or finds a pattern within the given data without a supervised output. Kaning unsupervised learning, gingamit ni siya og machine learning algorithms para maka-analyze og maka-cluster sa mga unlabeled datasets. So, unsaon man sa machine learning algorithm pag-cluster sa mga unlabeled datasets. So, kaning pag-cluster, mura siya og data mining technique. So, iyahang i-grupo-grupo tong mga unlabeled nga data according to its similarities and differences. So, by that, ang kaning machine learning algorithm, ma-discover niya ang mga hidden patterns didto nga data. So, dili na kinahanglan nga naa pa human intervention mo nang gitawag siya og unsupervised. Let's suppose that we observe a response Y and P different predictors. X equals x sub 1, x sub 2, and so on. So, we assume that there is a relationship between y and x equals x sub 1, x sub 2, and so on. So, in general, we can say y equals fx plus e. Here, f is an unknown function and e is the random error term. In essence, statistical learning refers to a set of approaches for estimating f. Here, f is fixed but an unknown function of x sub 1, x sub 2, and so on. And e is a random error term with mean 0, which is independent of x and has mean 0. In this formulation, f represents the systematic information that x provides about y. The idea of statistical learning deals with several approaches to estimating the function f. The reasons behind estimating the function f are twofold, namely prediction and inference. In many real-life problems, the information about the input variables are readily available. However, the output y is difficult to obtain. So statistical methods and artificial intelligence are very useful in obtaining information about the unknown state of nature of the parameter. Statistical learning plays a key role in many areas of science, finance, and industry. Statistical learning is used to build predictive models based on the data. It can be used to build applications for computer vision, text analytics, voice recognition, and etc. Some examples of the learning problems are: predict whether a patient hospitalized due to a heart attack will have a second heart attack. The prediction here is to be based on demographic, diet, and clinical measurements for that patient. Predict the price of a stock in 6 months from now on the basis of company performance measures and economic data. Estimate the amount of glucose in the blood of a diabetic person from the infrared absorption spectrum of that person's blood. Identify the risk factors for prostate cancer based on clinical and demographic variables. In essence, a statistical learning problem is learning from the data. In a typical scenario, we have an outcome measurement, usually quantitative, such as a stock price, or categorical, such as heart attack or no heart attack, that we wish to predict based on a set of features, such as diet and clinical measurements. We have a training set which is used to observe the outcome and feature measurements for a set of objects. Using this data, we build a prediction model or a statistical learner, which enables us to predict the outcome for a set of new unseen objects. A good learner is one that accurately predicts such an outcome.
I will discuss the overview of inductive learning. Machine learning is one of the most important subfields of artificial intelligence. It has been viewed as a viable way of avoiding the knowledge bottleneck problem in developing knowledge-based systems. Ang machine learning, considered niya siya as one of the most important subfields of artificial intelligence tungod kay gialaw niya ang software application to become more accurate at predicting outcomes. Inductive learning, also known as concept learning, is how artificial intelligence systems attempt to use a generalized rule to carry out observations. Ang inductive learning is a process of discovering rules by observing examples and to see if there is a pattern. Kung naa na siya pattern nga makita, mo try na siya og apply sa rule sa lain-lain nga sitwasyon para makita kung mo-work ba siya in different situations. Inductive learning algorithm is an iterative and inductive machine learning algorithm which is used for generating a set of classification rule which produces rules of the form f then for a set of examples, producing rules at each iteration and appending to the set of rules. Kaning f din nga rules mo ni siya ang mo determine sa state sa entity sa every iteration step sa learning. Ani makita kung unsaon para mausab ang learning every time nga magdugang siya og daghan pa nga mga rules given nga naa na siya existing rule set. So kung ang output og example sa function nahatag na sa AI system, ang inductive learning mo attempt na ni siya og learn sa function para sa new data. Basic idea. There are basically two methods for knowledge extraction. Firstly, from domain experts and then with machine learning. Sa mga large amount nga data, dili kayo useful o reliable ang domain expert. Mao nang move ta ari sa machine learning approach. Para sa paggamit aning machine learning, usa ka method ang mo replicate sa experts logic in the form of algorithms. Pero kani nga work dugay kaayo. Mao nang move ta ari sa induction algorithms, which itself mo generate siya og strategy sa pag-perform sa task nga dili na manginahanglan og instruction sa kada step. According to Jason Brownlee in his article, Basic Concepts in Machine Learning, an excellent method to understand how inductive learning works is, for example, if we are given input samples X and output samples Fx from the perspective of inductive learning, and the problem is to estimate the function f. Some practical examples of induction are credit risk assessment. The X is the property of the customer. The Fx is the credit approved or not. Disease diagnosis. The X is the characteristics of a given patient. The Fx is the patient's disease. Face recognition. The X are bitmaps of the faces we want to recognize. The Fx is the name assigned to that face. Automatic steering and autonomous driving. The X is bitmap images from a camera in the front of the car. The Fx is the degree to which the steering wheel should be turned. Arita sa disease diagnosis. The X is the characteristics of a given patient. So ibutang na to, ang atong X is high body temperature. And ang atong ibutang sa Fx, kaya ang nakabutang Fx is the patient's disease. So ang atong ibutang sa Fx is pwede ang fever. Applications. Inductive learning may be helpful in the following four situations. Problems in which no human expertise is available. Humans can complete the task but no one knows how to do it. Problems where the desired function is frequently changing. Problems where each user requires a unique function.
Thank you so much for watching our video presentation.